The Industrial Revolution of the last century changed our civilization's way of life. Today, a second revolution has begun, the computer revolution. The Dartmouth time-sharing system has made the services of our GE 235 high-speed computer readily available to students and faculty at no charge. The computer can be used by 40 students at one time, almost 16 hours a day. This is a freshman class in finite mathematics taught by Professor John Kemeny, chairman of the math department.
Your next assignment will be the solution of a quintic or fifth-degree equation. This is particularly interesting because mathematicians have proved that there is no general formula for the solution of a quintic equation. I will illustrate the method in terms of this diagram. This is the graph of the quintic x to the fifth plus 2x cubed minus 1. We note that the graph is below the x-axis at 0 and above the x-axis at 1. Therefore, somewhere in between, the graph must cross the axis. And this is the value of x that we are looking for. We will use nothing more difficult than the fact that if the function is negative at one point and positive at another point, then there must be a 0 in between. We first examine the point 1/2. We note that the quintic is negative at this point. Therefore, the root must lie between 1/2 and 1. We again bisect the interval, picking the point 3/4, and we note this time that the value of the function is positive. Therefore, the root lies between 1/2 and 3/4. Each time we iterate this method, we cut the interval in half, and by iterating it enough times, we may find the root as accurately as desired. For example, if we iterate it 20 times, we will find the root to the nearest 1/1,000,000th. And 20 iterations take a negligible amount of computing time. Therefore, this is an extremely efficient method of universal value. You will also find that writing a program for it in BASIC is very simple. Writing this program in BASIC is your next assignment.
In the early days of high-speed computers, man was forced to learn a highly unnatural language to communicate with the machine. We have progressed a great deal since that time. Here at Dartmouth, Professor Thomas Kurtz, director of the Computation Center, and Professor Kemeny, with the help of several undergraduates, have written a language called BASIC, which is ideally suited for communication with the machine. It is a simple combination of ordinary English and algebra, which can be mastered by the novice in a very few hours. He can become quite expert with the language in 2 weeks, and yet he will find there is enough power in the language BASIC to solve the most complicated computer problems. 80% of all freshmen at Dartmouth now learn how to use the computer. The secret of our unique success has been the combination of the Dartmouth time-sharing system and the language BASIC. To help students in writing programs assigned in class, special programs have been set up which will test the students' programs. The computer will try the program under varying circumstances. And if the program is not quite correct, we'll type out an error message with an indication of where the mistake is. The mistake can be corrected simply by retyping the line number and typing the line correctly. The Dartmouth time-sharing system can be used by 40 people at one time. A program is typed out on any of the teletypes and is received and stored by the DataNet 30, the master computer. When the program is complete, the DataNet 30 sends the complete program to the GE235, the slave computer. The results of the computations are then sent back to the DataNet 30, which relays them to the teletype. Computation by the GE235 rarely takes more than several seconds, so it is able to begin work on several other problems while the DataNet 30 takes over the task of typing out the answers. A user can also draw on the program library stored in the memory disks for saved programs or data. The computer system has proved especially useful to the Thayer School of Engineering. This is Dean Myron Tribus.
The work John Kemeny and his colleagues have done in developing the time-shared system and basic language have already had an important influence on engineering practice in the United States. The Dartmouth system and BASIC are now in common use in several large engineering companies. We at Thayer School have been extremely fortunate to have been in on this development from the very beginning. I would estimate that our students can now turn out numerical computations at a rate at least 10 times greater than they could before.
The program library includes programs for many different uses besides those for math and engineering students. Transposing music, for example. Writing letters home and elsewhere. Income tax forms. Compiling concordances of an author's work. Or for computation of medical analyses.
The new Kiewit Computation Center is now under construction next to the Bradley Center for Mathematics. Soon it will house a GE625 time-sharing computing system. This will be able to serve 200 users all at the same time and will provide educational computation for northern New England. I would like to predict that in the near future, our computation center will play as fundamental a role in the life of the undergraduate as did the library in the past.